All right, we're in section 1.6 with relations and in Algebra 1 here. So let's get rolling here. What we're going to do is we're going to represent relations and interpret graphs. Okay, so we can start talking about a coordinate system. I think you've seen these before. They're formed by the intersection of the x and y axis. So we've seen something that looks like this, with this being your x-axis over here and this being your y-axis up and down. Okay, an ordered pair is a set of numbers written as x, y coordinates, and we know our x-coordinate, that is your horizontal placement of a point, left and right, and we should know that the positive moves you right, negative moves you left, and the y-coordinate is the vertical placement of a point, and we should also know that positive goes up, negative moves down with your y-coordinate. So just to review those as well. Domain and range. So your domain is a set of the first numbers of the ordered pairs. You might not have heard these terms, maybe you have. And your range ends up as the set of the second numbers of the ordered pairs. So really what you're talking about here is the domain is your x value, and then your range is the y value of your ordered pairs. Okay, and you may have heard domain and range. You might not have heard about independent and dependent variables, and so we're kind of going to talk about those today. But when we talk about them, I'm going to separate them like this on purpose because they have a connection between the domain and range as well. So your independent variable, one way of thinking about that is the variable that determines the output, or really the set of numbers you get to choose from. So if you remember yesterday with, or the last lesson with equations, when we talked about the replacement set, those are the numbers you could choose. Those were your x values that you plugged in to determine the output. And then your dependent variable is the solution you get, the value that you get after using the independent value. So we plugged in those x values, and then we got a y value. So when we look at these ones, we're thinking independent variable really is your x, because that's what you plugged in all those equations. And then your y value was the answer you got after you plugged in the x. So we talk about dependent variable. The y depends on what you did for x. It depended on what the x value was. So in this case, the y value, or the dependent variable, really it depends on what you do for x. What number you plugged in for x got you a certain y. So it depends on it, which makes the dependent variable. Okay. The next thing is a relation. So what is a relation? Another way of saying a set of ordered pairs. Set of ordered pairs. And we got 4 different ways in which we can represent it. And they're all pretty simple. And so one way is, we could keep it in ordered pairs. Just keep it how it is. So let's say it was the point 4, 5. We could do that. That's one way. I'm going to rewrite my 5 there. Don't like it. I'm going to start doing that. I don't like that either. I'm just going to go ahead and restart that one. 4, 5. Okay. That's one way to do it, is leave it as ordered pairs. The next way is to make a table. So you're going to put a little t table here, put your x values on the left side, the y values on the other side. That's the second way. The third way would be to make a graph. So we've got our x-y axis, and you'd plot your points, your x value, y value, say a point there, maybe a point down here and a point over here. And you don't have to connect those dots, you just leave them there. And the fourth way is maybe the way that you haven't seen before, or with mapping. What that is, you just kind of take these 2 bubbles, and you put your x values in this bubble here, and your y value in this bubble here, and then you kind of map the numbers to what x gives you a certain y. You just kind of map them from one place to the other. So those are the 4 ways we're going to represent them, and so we're going to do some work with that, showing how we represent these pairs. So practice problem here: express the relation of those points as a table, a graph, and a mapping. So we've got our ordered pairs listed up here. We've got our ordered pairs, and they are, you know, right over here. This is our ordered pairs. Okay, so we've got 4 of those. And then what we're going to end up doing here as we put it as a table first, we're just going to kind of write our make our XY table. Okay, and so we'll just use those patterns. So our X values are 3, -1. Those are the first numbers, 0 and -3. Those are the first numbers in each ordered pair. And the Y's are the second number. If you remember, it's X comma Y. So the Y's would be the next number. So we can go 2, 4, -3, and 4. Okay, so that's your table. Okay, the next thing you could do is on the graph, we just plot these points. So we go X, Y, so we go X first, so 3, 2. My board's a little off, but in a small graph, I'll do the best I can. -1, 4, so we're going to go backwards 1, up 4, somewhere in there. 0, -3, should be there. And then -3, +4 would be up here somewhere. Okay, and you don't have to connect those dots, just leave them as points as they are. Now the mapping, again, we're going to go 3, and I'll just use different colors for these mappings to show you. -1, so all our X values, 0, and -3. And then your Y values are where they map to. So in this case, you've got your 3. It's going to come over and map right to a 3. Your -1 is going to map to your 4. And your 0 is going to map over to your positive, or excuse me, your -3. And then we've got a situation with the -3 where it also maps to 4. So I don't have to write another 4 in here. I just draw my arrow up to this 4 because 4 gets mapped to twice. So no big deal with the mapping. So that's how you do it. And it doesn't matter the order in your mapping. It really doesn't matter order of the table. I don't really care about the order there. It does matter when you, on part B here, when you determine the domain and range. So in this one, we're actually going to write in order for these ones, in order from smallest to biggest. So we want to write those in order. So your domain, that's basically your X values, And we write the domain, we're going to write it in as a solution set, or they call this set notation. So in order from smallest to biggest here, we'd go -3, -1, 0, and 3, and that's your X values. And then your range is your Y values. And in order again, -3, 2, and 4. So they don't really know, because you're putting them in order from smallest to greatest, that you don't really know with domain and range sets which numbers map to which numbers. It's just kind of on your own to figure that out. But the tables help that, and the mapping helps that out as well. Okay, but order doesn't matter. An easy way to look at it is, where did I get these values from for the domain? I can just kind of look up here. That's an easy way to do it. And also an easy way to do it is look at the mapping ones. That's an easy way to get your domain and range. Just put them in order. Okay? All right, next one, number 2, identify the independent and dependent variables in each situation. So the first one, letter A, the cost of going to a movie has increased over the years. All right, so we've got to think graphically here. If we just kind of put a X and Y axis down, so we've got X here and our Y here, and we got to think about what we're dealing with. We've got 2 things going on here. We have the cost of going to a movie, and we've got a time value of over the years. Okay, so what's the independent and dependent variable in this situation? So what depends on what? Does the years depend on the cost of going to a movie, or does the cost of going to a movie depend on the year? Well, in this case, it depends on the year. Maybe back in the 80s, it was a lot cheaper to go to the movies than it is now. So the years do not depend on the movie. The cost depends on what happens, what time it is with the year. So in this case, your years are going to be your independent variable down here. And remember, your X is independent. and the dependent variable is your y value, dependent. And so that is actually going to be the cost of going to the movies. So the cost would be over here. So we can actually write those up here and say that's our answer, that the cost of going to the movie is your dependent variable, and the time, the years, is your independent variable. Okay? So again, let's try letter B. As the temperature increases, the sale of winter coats decreases. So you got a couple things going on here with, you've got temperature's rising, and then you've got a sale of winter coats, Okay, so you got two things going on. So again, if we look graphically here, we're going to go X down here, Y right here, and we're trying to find independent and dependent variables. So what depends on which here? Does the temperature depend on winter coats? If it's warmer or colder? Not really. But does the sale of winter coats depend on the temperature? Sure. The temperature gets warmer, you're not going to need your winter coats. So the dependent variable would be, in this case, your temperature. Excuse me, the independent variable would be the temperature, because that's just going to stay what it is. And it doesn't depend on coats. The coats actually depend on the temperature. So your coats, sales of the coats would go here as your dependent variable, because that's really dependent on the weather. No one's going to buy winter coats in the summer. I know you might get a deal out of it or something, but that's generally what happens. So in this case, our independent variable was the temperature, and our dependent variable was the sale of winter coats. Okay? All right. Next thing we're going to talk about is, and this is the last thing we're going to talk about here, is describe what's happening in each graph. And it says be specific. So let's just look at letter B, and you guys can work with A on your own, but letter B, driving to school. So basically what we want to do is we want to describe what's happening in each graph each time there's a break in the graph. So this is distance and time driving to school. And you can kind of create a little situation. You can kind of be creative and make up your own little story. But remember, it just has to involve driving to school at some point. So you can say what roads or those things can change and what you do. But this first one, we go up really steep here in a short amount of time. So what that's going to tell us is that we're probably driving fast. So one example would be, okay, I'm driving fast down King Road. Okay, and then we have a little change in the graph. Notice now it goes basically straight sideways, so we're not going any distance. So what do you think that means? If you're not getting anywhere on distance, you're going straight across, but time is happening, what's happening to your car? It stopped. It stopped. So we're stopped here. So maybe, let's say on your way to school, what happens? Why would you have to stop all the time? Maybe it's a traffic light, but let's say that there's, you got stopped behind a bus. That's another reason why you would have to stop. So time goes by, and there's a bus there. Okay? So next up is, it goes a little bit slightly up and to the right, so time is elapsing, but now we're not going as fast as we did earlier, so maybe we're driving a little slower. So let's say that bus took off, and now we're following the bus. It didn't let us go by, so now we followed the bus. Okay? And then we had to stop again. All right, so let's just go with we're stopped again, so then stopped. Maybe it's a light this time, or maybe it's, maybe it's the bus stopped again. And let's say the bus got rid of us, and then we kept driving to school. So then keep driving. Kept driving to finish it off. So basically you're taking every little piece of the graph, and every time it makes a break and changes, then we're going to describe what's happening. Right? So that's one way. In this section here, you notice that we only have 3 things that happen. You go for a little bit, and then you are stopped for a while, and then you go for a little bit again. So there's only 3 real sections to have to make up there. Okay, but you can be creative. It doesn't have to be King Road. It doesn't have to be a bus that stops you, because there's other things that you can do. But be creative, but just kind of keep involved with the labels. We didn't really use them a whole lot with distance and time, but you kind of want to be specific using distance and time driving to school. Okay? All right, lesson summary. Describe the difference between the domain and range. And then your practice problem here, identify the independent and dependent variables for the function. And your function here down below is the number of calories you burn increases as the number of minutes that you exercise increases. So with that problem there, your function is the number of calories increasing versus the minutes that you exercise. And so identify the independent and dependent variable of those. Okay, that's it for 1-6. Let's make sure that we bring questions with us, and we're ready to rock on this tomorrow.